This video looks at the particle model of matter. Firstly, we need to consider what is a model. So in this context, a model is a way of understanding something. It's based on observations and experiments, and it makes assumptions. In science, we use models a lot, often because things are way too big or way too small to see, and also because situations are often very complex, and models can help us to visualize them or to represent them or to understand them in a way that's more meaningful. Models allow us to make generalizations to help us understand what's going on. So we need to be aware of and to understand the exceptions and limitations as well. So we need to realize that a model doesn't explain every single situation that there is, that there are exceptions to particular things, and that each model does have its limitations. And indeed, for some things, there might be several different models that explain the observations and experiments about that particular concept. So models aren't perfect, but they're still very good, and we just need to understand and be aware of the exceptions and limitations. So, what is the particle model? The particle model of matter says that all matter is made up of particles which are far too small to see. The particles of matter are always moving. The particles have spaces between them, and that adding heat to matter makes the particles move faster. The structure and properties of the matter are linked to the behavior of the particles. And we most often talk about the particle model when we're looking at physical states of solid, liquid, and gas, and at the changes between them. The particle theory of matter says that the particles have very little energy in solids. They're barely moving at all, they're just vibrating. They're barely moving at all. They're quite tightly packed together with very little space between the particles, and that means that the solid has a fixed shape. So an analogy for this, if you think about students during class time, so during a particular lesson, most students will be sitting in classrooms. There won't be much space between them. They'll mostly be sitting at desks in groups or in rows or at benches in the lab or whatever. They won't be moving about much. They'll be moving, that person might lean over to grab something from that person might get up to put something in the bin, that person might get up to ask that person a question. People might be moving around within the classroom, but they're not moving much compared to the whole area of the school, and mostly they're staying where they are. The particle theory of matter says that in liquids, particles have a medium amount of energy. The particles move around and there's some space between each particle. Liquids will take the shape of its container, but it will keep a fixed volume. So that's why if you pour liquid into a curvy vase or something, it will take on that curve. If you pour liquid into a tall, skinny measuring cylinder, then it will make a tall cylinder. If you pour it into a square lunchbox, then it will take on that rectangularish shape. But it keeps a fixed volume. It doesn't, as long as it fits within that container, it won't leave the container. So an analogy for this is at lunchtime when students are moving about freely within allowed areas and within boundaries. So you might have some students who go down to the bottom courts, or some students who go down to the oval, or some students who go up to the library. So students are moving around a lot more than they were when they were in class. They're going to their locker, then to wherever they sit to eat, then to wherever they're going to do whatever they're going to do for lunchtime. There's a lot more space between students and they're moving around a lot more freely, but they're still staying within the confines of the campus. Now we're going to have a look at gas. So the particle theory of matter says that the particles in a gas have a large amount of energy. The particles move around a great deal and very quickly, and they can get very far away from each other. A gas will fill the whole space in all directions to a limit. So a gas does not have a fixed volume. So it will overflow from a container if that container isn't enclosed. Remember, we're talking here about generally. There might be reasons why that might not occur, but the model says that generally that will happen. So that's why sometimes if you're having a barbecue and there's a gas leak, you might be able to smell that gas from quite a distance away because the particles are moving very quickly and they can move about and increase the volume a lot because they can have large spaces between them. So to return to our schoolyard analogy, this would be like at the end of the day when students are leaving campus and they're going in many directions. A lot of students are moving a lot more quickly than they were during the day because now they've hopped in the bus or a car or on a bike. And most students are moving much further away from each other than when they were sitting next to each other in the classrooms or when they were moving about within the campus at lunchtime. So now they've got more energy, they've got larger spaces between them, they're moving more quickly and they're taking up much, much, much more space. Now, at this point, the students are covering numerous suburbs, whereas before they were all contained within the school. I just briefly want to mention plasma here because it is a state of matter, but like solid, liquid, and gas, but it doesn't freely exist on Earth under normal circumstances. It's well beyond the scope of grade 8 science, but I did just want to mention it while we were talking about solids, liquids, and gases. Changing between states. Changing between states of matter is a physical change. The most common example which you see is changing from ice to water to steam and back again. But we see this with many elements and compounds. We also use the particle model of matter to help us to understand these changes, and we'll look at that further later. In summary, scientists use models to help us to understand phenomena. The particle model of matter says that all matter is made up of moving particles. The structure and properties of matter are related to how much energy the particles have, how much space is between the particles, and how the particles move. The particle model of matter helps us to understand the properties of solids, liquids, and gases. The particle model of matter also helps us to understand other concepts such as state changes and physical change and many other aspects